Understanding why CPU sockets keep changing helps you make smarter buying decisions and avoid hidden upgrade costs. Every time Intel or AMD changes their CPU socket, you probably think it is because of improved technology. You are only half right. The real story is that socket changes serve two masters: technical progress and business strategy. Today, I am going to show you what really determines motherboard compatibility, why the AM5 and LGA 1700 transitions cost more than you think, and the hidden price of staying loyal to one platform. This isn't just a tech explainer. It is the math they don't want you to calculate. A CPU socket is the physical interface between your processor and motherboard. Think of it like an electrical outlet for your computer's brain. Your CPU needs three things from this connection: power delivery to run its circuits, data pathways for communication with memory and components, and thermal support through the IHS contact. The socket architecture determines how efficiently all three of these needs are met. It is not just a connector, it is the foundation your entire system builds upon. Modern CPUs demand more power than their predecessors, and this is a major driver of socket changes. AMD's AM5 supports 170 watts sustained, compared to AM4's 105 watts. That is over 60% more power delivery. This requires thicker power traces on the motherboard, better voltage regulator modules, and completely redesigned power delivery circuits. The socket pins themselves must handle significantly more current without overheating or degrading. This isn't a minor specification bump. It is a fundamental electrical redesign that makes new hardware necessary. Intel's LGA 1200 had 1,200 pins. LGA 1700 has 1,700 pins. That is 42% more pins in the same generation span. But here is what most people don't realize. Not all those pins are for power delivery. Many carry signals for entirely new features like DDR5 memory support, PCIe 5.0 lanes, and communication between performance and efficiency cores. The physical socket size increased from 37.5 mm to 40 mm to accommodate this additional connectivity. More pins means more capabilities, but also more complexity in the motherboard design. When AMD moved from Zen 3 to Zen 4, they didn't just increase clock speeds. The entire memory controller fundamentally changed. DDR5 requires different electrical signaling protocols, different voltage requirements at 1.1V compared to DDR4's 1.2V, and completely different compatibility matrices. This isn't something a BIOS update can patch around. The memory controller changes at a hardware level, requiring new pins, new power rails, and new signaling pathways. This is why you can't drop a Ryzen 7000 CPU into an AM4 motherboard, even if you somehow physically forced it. Intel's 12th generation introduced hybrid architecture, mixing performance cores with efficiency cores on the same die. These two core types communicate differently, require completely different power management strategies, and demand more sophisticated thread direction logic to decide which tasks go where. The LGA 1700 socket wasn't just about adding more pins. It was about supporting this fundamentally different chip architecture. The socket had to accommodate new intercore communication pathways and power delivery configurations that simply didn't exist in previous designs. Socket changes are partly technical, but mostly business decisions. If AMD kept AM4 with DDR5 support, you'd have fewer reasons to buy a new motherboard. If Intel allowed 12th gen CPUs and 600 series boards without changes, fewer people would upgrade. Every socket change forces consumers to reinvest in motherboards, which benefits both CPU manufacturers and motherboard makers. This isn't a conspiracy, it is standard business practice. But understanding this reality helps you make smarter purchasing decisions. The technology is real, but so is the commercial motivation driving the timeline. What actually determines if a CPU works with a motherboard? Three things: socket compatibility, chipset support, and BIOS compatibility. A CPU might physically fit into a socket but not function if the chipset doesn't support its features, or if the BIOS doesn't recognize the CPU's identification and capabilities. This three-layer system is why compatibility isn't as simple as checking the socket type. Many people learn this the hard way when they buy a CPU, install it, and get no video output because the BIOS needs updating first. The chipset is essentially the motherboard's traffic controller. It determines which features are available, how many USB ports you get, what storage speeds your NVMe drives can achieve, and critically, which CPU generations the board officially supports. Intel's Z690 chipset supported 12th gen processors, but initially couldn't support 13th gen without a BIOS update. This is because the chipset has its own firmware that needs to recognize and properly configure the CPU. The chipset essentially translates between your CPU and all your peripheral devices. When you buy a newer CPU for an older motherboard, you often need a BIOS update first. This happens because the motherboard's firmware doesn't recognize the new CPU's identification and feature set. The BIOS acts as a bridge between hardware and operating system, and when a CPU is too new, the BIOS doesn't know how to initialize it properly. AMD's BIOS flashback feature exists specifically to solve this problem. It lets you update the BIOS using a USB drive without any CPU installed. This feature exists purely because of this compatibility gap. AMD's AM4 socket lasted from 2016 to 2022, an incredible 6 years of platform support. During this time, you could upgrade from a budget Ryzen 3 1200 to a flagship Ryzen 9 5950X on the exact same motherboard. That is 6 years of upgradability with a single board investment. Users started on DDR4 and didn't need to change when upgrading through multiple generations. This is why people loved AM4 and why it set expectations that AMD would struggle to match with future platforms. When AM5 launched, AMD broke the pattern that made them beloved. DDR5 only support meant you couldn't reuse your DDR4 RAM investment. New cooling solutions were required because the IHS thickness changed thermal characteristics. The socket mounting mechanism changed, invalidating many existing coolers. The platform was essentially a complete rebuild. Your M4 ecosystem couldn't transfer. This wasn't just an evolution from AM4, it was a clean break that forced complete system reinvestment. Intel's LGA 1700 was used across 3 generations, 12th, 13th, and 14th gen, roughly 3 years of platform support. If you bought a Z690 board at launch, you've now seen 3 generations of CPU upgrades on the same platform. This is decent, but not exceptional. Intel has historically been known for shorter platform lifespans, which creates a different upgrade calculus compared to AMD's approach. You get consistency within the generation, but sooner obsolescence. The DDR4 to DDR5 transition carries a significant memory cost. A typical 32GB DDR4 kit costs around $60 to $80. A comparable DDR5 kit runs $120 to $150. That is a $60 to $90 premium just to switch memory standards, not counting any performance gains you might achieve. This cost applies whether you are building new or upgrading, and it doesn't factor into the CPU or motherboard price tags. It is a silent addition to every platform transition that impacts your total investment. AMD changed the mounting mechanism for AM5. Many AM4 coolers needed new mounting brackets, and some AO liquid coolers required complete redesigns for the new platform. Intel's LGA 1700 had different mounting hole spacing compared to LGA 1200, making old coolers physically incompatible without adapter kits. These adapters aren't always provided by cooler manufacturers, and when they are, they sometimes affect thermal performance. Your existing cooling investment becomes partially or fully worthless with each platform change. A mid-range Z690 or B650 motherboard typically costs $150 to $250. When you switch platforms, this entire investment becomes worthless unless you find a legitimate use for a second PC. Most builders don't have a server or secondary system that needs a spare motherboard. That $200 board you bought last generation becomes e-waste or a paperweight when you upgrade. Platform loyalty means accepting this recurring investment loss with every major CPU generation change. Every platform has different BIOS options, overclocking procedures, and firmware quirks. Switching platforms means relearning your system's configuration from scratch. Memory timing adjustments, voltage curves, fan curves, these all work differently between manufacturers and even between chipset generations. This learning period costs you time and can lead to suboptimal settings during the adjustment phase. Some users never fully optimize their new platform because they don't have time to relearn everything. This hidden cost compounds with each platform switch. Certain devices work reliably on specific platforms, but may have issues on others. Thunderbolt devices often require Intel-specific implementations. Some USB audio interfaces perform differently depending on chipset. Certain expansion cards with specialized drivers may only work properly with specific platform implementations. When switching CPUs and platforms, you might find that expensive peripherals no longer work as expected. Some users end up replacing devices that worked perfectly before the platform change. Let's calculate a real upgrade scenario from AM4 to AM5. New motherboard, $200. New RAM, because DDR5 only $130. New cooler or mounting adapter, $30. That is $360 total, just for the platform change. Before buying any CPU, if you owned an AM4 system worth $500 total, you've essentially spent $360 to upgrade a $500 system to a new platform. The CPU you add on top of that represents the actual performance improvement. This math changes how you should evaluate platform decisions. Socket changes benefit manufacturers in three specific ways. First, they force platform purchases, since old boards won't work with new CPUs. Second, they allow feature improvements that genuinely wouldn't be possible with old hardware specifications. Third, they create revenue from ecosystem lock-in. Your platform loyalty doesn't benefit you. It costs you money while generating revenue for the entire supply chain. Understanding this motivation helps you see through marketing claims about platform improvements. Intel follows a strategy of short socket life, typically supporting only 2 to 3 CPU generations before requiring a new motherboard. This forces regular platform investments. AMD historically offered longer platform support, with AM4 lasting 6 years. But recent AM5 broke that pattern with a forced DDR5 transition. Intel offers consistency within generations, but requires more frequent full rebuilds. AMD offered longevity but recently changed approaches. Neither strategy is objectively better. It depends on your upgrade habits. Looking at socket history, M4 lasted 6 years and supported 4+ CPU generations. LGA 1700 lasted 3 years with 3 generations. LGA 1200 lasted just 1 year with 2 generations. LGA 1151 lasted 4 years, supporting 4+ generations. Your platform choice directly impacts your upgrade path value. A longer socket life means more upgrade options without reinvesting in the entire ecosystem. This historical perspective should inform your purchasing decisions today. When evaluating CPU and motherboard compatibility, check 4 things. First, does the CPU physically match the socket type? Second, does the motherboard chipset officially support the CPU generation? Third, is the BIOS firmware updated to recognize the specific CPU? Fourth, can the power delivery system handle the CPU's TDP and power demands? All 4 conditions must be met for reliable operation. Missing any one of these checks can result in no boot, instability, or missing features. Not all motherboard features work with all compatible CPUs. Some 12th generation features require Z690 specifically. Some AM5 features require X670E chipsets, while B650 boards offer reduced capabilities. Understanding these limitations prevents disappointing purchases. A CPU might physically fit and boot on a board, but you might not get the full feature set you paid for. Always verify that your specific combination supports the features you need, not just basic functionality. Calculate your personal platform loyalty cost using this formula. Take your average time between platform changes, multiply by the average cost of each platform upgrade, then divide by your average years between building new systems. Higher numbers mean platform loyalty costs you more. If you upgrade every 3 years but platforms last 6 years, you are paying for half a platform you never use. Do this math before your next purchase to understand your true costs. 3 things manufacturers don't advertise about platform changes. First, how long your platform will actually receive CPU support. Second, how much you'll spend on ecosystem changes including RAM and cooling. Third, whether new features actually require new hardware or are software limited and could work on older platforms. Until we know the answers to these questions, consumers can't make informed decisions. The industry benefits from this information asymmetry. Before choosing a platform, ask yourself 4 questions. How long do you plan to keep this build? What is your total platform cost including RAM and cooling, not just the CPU and motherboard? What CPU generations will this platform support in the future? Is the upgrade path worth the investment compared to starting fresh with a new platform? Your answers determine whether platform loyalty makes financial sense for your specific situation. Comparing current platforms, M5 advantages include PCIe 5.0 support, DDR5 future-proofing, and 170-watt TDP headroom. Cons are the DDR5 cost premium and new cooling requirements with no DDR4 option. LGA 1700 advantages include a more mature platform with more board options at various price points. Cons are only 3 generations of support and potentially higher total platform cost due to board pricing. Neither is clearly better. The right choice depends on your specific needs and timeline. The real reason sockets change is business sustainability. Research and development costs money. Motherboard manufacturers need to sell boards to stay in business. CPU manufacturers need upgrade incentives to drive sales. The technology driving socket changes is real and necessary, but so is the business model that determines timing. Understanding that both factors coexist helps you see through marketing and make rational purchasing decisions based on your actual needs rather than manufactured urgency. Platform loyalty isn't inherently bad, but blind loyalty costs money. Understand your upgrade timeline before buying. Budget for total platform costs, not just CPU and motherboard. Research socket longevity before committing. And remember, every time they change the socket, it is not just technology, it is a business decision that directly affects your wallet. The best platform isn't always the newest. Sometimes a mature platform with lower ecosystem costs beats a shiny new socket with hidden expenses. Do your math, understand your needs, and build smart.